Assalamu alaikum and good evening, everyone. Today we are going to start May June 2023 paper 4.1. Let's start with question number 1. A student uses chromatography to separate the dyes in food coloring. Okay. Figure 1.1 shows the apparatus that the student uses. Okay. So name the apparatus X. So very good, Kamar. We know that this is the beaker in which that the chromatography paper has been placed. State why it is important to have a lid on X. See, the solvent, whenever we put the lid, it means we need to prevent the evaporation of the solvent from the beaker. Sometimes there are organic solvents which are volatile and having a low boiling point. So if you don't put the lid over here on the top, then the solvent would evaporate. So you are not able to perform the chromatography properly. If the solvent is water, for example, then there is a no need of lid. But if the solvent is organic compound which have a low melting point, then this lid is mandatory. Not water vapors, Rahim. That's what I am explaining. Because water will not evaporate easily. The other solvents. To prevent evaporation of solvent. Now, state why the straight line is above the level of solvent and drawn in pencil. So it is because if, for example, solvent is like this, so the dye which we put over here is dissolved off the paper and move in the solvent. So that's why we do not, we keep the level of the solvent below or the line above the solvent. So the dye does not dissolve off the paper into the solvent. Is this understandable to all of you? Now drawn in pencil. So it does not dissolve and move up the paper along with solvent. Okay. Now, the RF value of one of the dye in the food coloring is 0.6 and the separation this travels 5.7 centimeter. Calculate the distance traveled by the solvent during the separation. Okay. So the RF value is equals to distance traveled by the dye and the distance traveled by the solvent, right? So they have given you the RF value, which is 0.60. This dye travels 5.7 centimeter, and the distance traveled by the solvent. So we have to calculate that. So it's X. So X is equals to 5.7 over 0.60. Okay, thank you, Kamar. So it's 9.5. Is this clear to all of you? Now, question number 2. White vinegar is a colorless solution containing ethanoic acid. Okay, you have to follow the things and the steps which they have tell you, otherwise you will, not going to get the marks. But it's easy. A student titrates 0.0400 mole per dm cube aqueous sodium hydroxide. So it means this is the concentration of sodium hydroxide with two samples of a vinegar A and B. The student does 4 titrations, 2 with A and 2 with B. The student. Okay. Step 1 uses a volumetric pipette to add 25 centimeter cube of 0.4 mole per dm cube. Okay, so that is the concentration sodium hydroxide to a conical flask. So that is the concentration of sodium hydroxide and that is the volume of sodium hydroxide. Add 5 drops of indicator into the conical flask. Add A from the burette while swirling the contents of the flask, adding drop by drop near the end point until the solution changes the color. Empties the conical flask, rinses it with distilled water, repeats step 1 to 4. Okay. Repeats step 1 to 5 using B instead of A. Okay, so 2 times they have used vinegar A and then 2 times they have used vinegar B. So if you recall vinegar, what is vinegar? Vinegar is the solution of a ethanoic acid. So it means they contains this ethanoic acid in them. Okay. Now, see, these are the very easy and the scoring marks. Figure 2.1 shows the burette reading for the 2 titrations with vinegar A. Initial final with titration 1 and titration 2 initial final. Record the burette readings in table 2.1, complete table 2.1 with the volume used in each titration. So if you see the initial burette reading of titration 1 is 0.00, sorry, 0.0, you have to put the answer into 1 decimal place. Which formula, Waleed? And for titration 2, it's 12.3. Now the final burette reading. For titration 1, it's 24.9. For titration 2, it's 37.4. So now we will subtract these values to find the answer. So here it is going to be 24.9 only. And here it is going to be 0.1, 25.1. Yes, the one which we are adding in the conical flask, we use the pipette. And the other one, no, there is no formula that they give you. You have to remember the formulas. 2. Figure 2.2 shows the burette reading for one of the titration with vinegar B. Record the burette readings for titration 4 in table 2.2. Calculate the volume of vinegar B added in titration 3 and 4. Okay. So in 3, we are given with the readings. We have to subtract it. So it is going to be 12.5. And for titration 4, the initial reading is 12.6. And the final reading is 25.3. If you subtract it, 13 minus 6 gives you 7. And here 12, 24 and 12. So 24.7. No, sorry. 12.7. Clear? Is this clear to all of you? If any one of you has any confusion, please ask. Okay. Now B. Calculate the mean volume of A and B needed to neutralize 25 centimeter cube of 4 mole per dm cube sodium hydroxide. So the mean volume of A is 25.1 and 24.9. So for A, 24.9 plus 25.1 divided by 2, it will give you 25.0, right? Mean volume of B, 12.5 plus 12.7 divided by 2 gives you 12.6. So here, 12.6. Which one, Waleed? The table is very easy. You have to subtract these two values to get this. In the second row, that is the initial burette reading, which we get from the first one. See, it's 12.6. And here it's 25.3. See? So The first one is the initial, so we put it in the initial. The second one is the final, we will put it in the final. Okay. Now, suggest why the titration A and B titrations using A and B are repeated. So the repetition is to check the consistency of the results that, or the consistency of the readings, that we are getting the same readings or a closer readings or not. To ensure that the results are consistent or not. Not accurate answer, but a precise answer. So we just check the consistency. D. The equation for the reaction between ethanoic acid and sodium hydroxide is shown. Okay. The answer to B shows the mean volume of B used to neutralize 25 centimeter cube of 0.4 mole per dm cube aqueous sodium hydroxide. Okay. Yes, here we have the volume of B, which is used to neutralize the 25 centimeter cube volume of this concentration of sodium hydroxide. Calculate the concentration of B in ethanoic acid. Concentration of ethanoic acid in B. Give your answer to appropriate number of significant figures. Okay, so see, we know the volume of sodium hydroxide. We know the concentration of sodium hydroxide. We know the volume of B that has been used, right? And the volume of B that has been used is the mean volume that we have calculated over here is 12.6. Right? So first what we will do, we will find the moles of sodium hydroxide. And to find the moles of sodium hydroxide, we will use the formula that the concentration of sodium hydroxide multiplied by volume of sodium hydroxide in decimeter cube. So the concentration of sodium hydroxide is 0.400. The volume of sodium hydroxide is 25.0, that is in centimeter cube. So we have to divide it by 1000 to turn into decimeter cube. Can anyone calculate the answer and tell me the answer, please? So we got the constant moles of sodium hydroxide. Now look at the equation. The ratio between the two substances are 1:1. So it means that we can take the mole ratio to find the moles of ethanoic acid. So the mole ratio is 1:1. It means if there are 0.01 moles of sodium hydroxide, the moles of ethanoic acid would be X. That X is equals to now 0.01 moles. Now see, these moles are present in this much volume. So we got the moles, we got the volume. Now we will easily find the concentration. The formula of concentration is moles over volume in decimeter cube. So the moles is 0.01, volume is 12.6, which is in centimeter cube, divided by 1000. Can anyone calculate it? Okay. So it is 0.793. Kamar, does there is any other figure than after 3? Any other digit after 3? It's 0.7936. So see, when you are quoting 3 figures, so you will round it off because the next figure is greater than 5. Use your answer to D to calculate the mass of ethanoic acid in 500 centimeter cube of B. So see, this is a mole per dm cube, which means these are the moles in 1 decimeter cube, and 1 decimeter cube is always equals to 1000 centimeter cube, right? So from this, we can find the moles. We make this ratio, that's 0.794 present in 1000 centimeter cube. So in 500 centimeter cube, how much moles are present? That is X. So if you calculate the value of X, X is 0.794 times 500 over 1000. So we got the moles from here. So the moles, can anyone calculate the moles? They have told you to in appropriate significant figures. And if you see this, they have used everywhere. This, all are them are in 3 significant figures, right, Shayan? So, or dividing, we get 0.397 moles. And they are asking the mass, the MR. So, mass is equals to moles times MR. Moles are 0.397 times 60. So can anyone calculate and tell me the answer, please? It's 23 point, you are getting 23.82, right? So if we write the 3 significant figures, it stays 23.8. Okay, now part F, use your answer to B and E to calculate the mass of ethanoic acid in 500 centimeter cube of A. Okay. So if you see over here that the volume used for A is almost double than the volume of B. So B and E, okay. So from part B, what information we are getting? That the volume of A is 25.0 and the volume of B is 12.6. Can anyone divide it and tell me the answer? Tell me the factor by which they differ. That is what we got from B. The ratio, it's 1.983, right? So by this ratio, the volume is differ. So it means the mass is also differ by the same ratio. So the mass in B is 23.8. So if I divide that 23.8 by this ratio, I'm able to get the mass of A in 500 centimeter cube. So can anyone divide it and tell me the answer? Okay, it's 1.984. Yes, can anyone divide it and tell me the answer, please? It's 11.999. So it means it is going to be 12.0, right? Okay. Now, G part, suggest why the conical flask is rinsed with distilled water and not with 0.4 mole per dm cube aqueous sodium hydroxide between titrations. Okay. So because if you see in conical flask, we would not measure. The measurement is taken in pipette and or in the burette, and after measuring in pipette, we transfer it in conical flask. So it is rinsed with distilled water to remove chemicals from it, and if we rinse it with sodium hydroxide, and if some NaOH would left in the flask, then more. Obviously, we are adding it after from the pipette, and there is due to the rinsing, there is some is left in the flask, and we have added 25 centimeter cube from the pipette. So now we have a more than 25 centimeter cube of NaOH in the flask. So for that, we need more volume of A and B, or A or B would be needed. No problem, Zainab. Some vinegars are brown rather than colorless. Suggest why this titration method would not be suitable for finding the concentration of ethanoic acid in the brown vinegar. So obviously the color change would not be, clearly observed. Just give me a minute, please, everyone. So the color change would not be observed properly. Okay, now question number 3. A student investigates a solution W and copper to carbonate. Okay. The test a student does on W are shown in table 3.1. Some of the observations for these tests are also shown. So these tests can be, rechecked with the help of, the table given in the end. See, what we do, we have a conical flask hammer, right? And we have a one pipette. That pipette has a volume capacity of 25 centimeter cube. So we fill that pipette with the 25 centimeter cube NaOH and transfer it over here. So if you rinsed it with sodium hydroxide, so some of the sodium hydroxide must be left over here. And when we transfer the NaOH with the burette, So there is a more amount of sodium hydroxide in it. And as a result, more volume of A and B that we are adding from the burette would be needed. So as a result, we are not going to get the correct result. Is it understandable, Umar? Okay. So add aqueous sodium hydroxide to W, solution remains colorless. Okay. So see, sodium hydroxide, always remember, aqueous sodium hydroxide is used for the cations. And if you are observing that the solution remains colorless, it means that there is a possibility of ammonium ion. Okay. There is a chance that it must be an ammonium ion and no metal ion in it. If you see over here, you can check it from here. If you see, for ammonium, ammonia is produced on warming with sodium hydroxide, but see no color. So it means when there is no color change has been seen, no precipitates have been observed by adding sodium hydroxide, it clearly means that there might be an ammonium ion. Okay. Add dilute nitric acid and then barium nitrate, white precipitate. So by adding barium nitrate, we are getting white precipitates. So these white precipitates are of barium sulfate, which means that W might contain sulfate ion in it. Is this understandable to all of you? One, two, now third. Add dilute hydrochloric acid and then aqueous silver nitrate to W. Okay. So white precipitates. So it means that these white precipitates are of silver chloride, and on adding silver nitrate when we get a white precipitate, so it means W also has a chloride ion in it. Flame test on W, no color is observed. Right? So it means if no color is observed on a flame test, it means none of these metal ions are present in it. Okay. Now, the student correctly concludes that ammonia is formed in test 1. Okay. Describe what else a student must have done to reach this conclusion. So that's what we have observed, that on heating, ammonia is produced if ammonium is there, and they have told you that ammonia is, student confirmed ammonia is present. So with ammonium, on adding aqueous sodium hydroxide, ammonia is produced on warming when if there is an ammonium ion. So I'm going to write this, that heat or warm the solution. Okay. Then test the gas formed with damp red litmus paper. It turns blue, and this observation, turning of a red litmus paper blue, shows that ammonia gas is present. State why the student cannot identify the anion in W from the observation in test 3. Yeah, but see, very good question. See, we are adding hydrochloric acid. So hydrochloric acid also contains chloride, and so there is doubtful that W has chloride or not, because we added hydrochloride ion ourselves. So adding hydrochloric acid introduces chloride ions in W. So if we add silver nitrate, obviously we are going to get the chloride, the test for the chloride positive, but the chloride has been added by us only. So we are not sure that W has chloride or not. Is this clear? Now, state how the test and observation show that W does not contain sodium ion. Okay. It is because uh, sodium ion gives a yellow flame, I think, on a flame test. If you see over here, yes, yellow flame, and they have told you that there is no change in flame. So gives yellow flame. Identify the cation and anion in W. So the cation that we have identified over here, if you see ammonium, and the anion is sulfate. So I'm going to write NH4 positive and SO4 2 negative. Till here, is this clear to all of you? Yes, very good, Shayan. Now B part. The student adds dilute hydrochloric acid to a copper 2 carbonate. A gas and a solution is formed. So see HCl and copper 2 carbonate. If you see, we will get copper chloride, water, and CO2. To balance the equation, you need to put 2 over here. State the observation that confirms the production of a gas. So how can we see when the gas is formed in the solution? We always observe effervescence, right? That is the test for carbon dioxide gas. They are saying that production of gas, it means any gas. So how can you see the observation? You can observe a production of a gas in a solution whenever you see the bubbles are forming, the effervescence are there. Okay. Now describe how to do a flame test to confirm the presence of a copper 2 ions. So yes, who can recall the flame test? Take some crystals on coiled wire and yeah, the wire loop. Yes, I'll upload it as soon as possible, okay? Or instead, you can write that make the loop wire and then dip the metal, not dip, yeah, dip the metal wire in the solid sample and then place it in the blue flame on the Bunsen burner. Okay. So take some crystals on the coiled wire and put it in the blue flame. What is the color of copper? For copper, if you see, it's a blue-green flame. Flame color changes to blue-green. Now describe one other method the student could use to confirm that the solution contains copper 2 ions. So it's very easy. Either you can use for a copper, where is copper? This one with the sodium hydroxide or this one with the aqueous ammonia. You can write any one. So add aqueous ammonia Blue precipitates are formed on adding excess aqueous ammonia blue PPT dissolves to form you can do with the sodium hydroxide as well. Blue solution. So with sodium hydroxide, you will write blue precipitates are formed, and on adding excess sodium hydroxide, blue precipitate remains insoluble. And here with aqueous ammonia, blue precipitate dissolves to form a dark blue solution. Is this clear to all of you? Now, question number 4. This is the designing experiment question. And in this question, you guys might get some difficulty. Baking powder is used to make cakes rise. When water is added to a baking powder, carbon dioxide is released. The longer the baking powder is stored, the less carbon dioxide it releases when water is added. Okay. So it means the one which is prepared earlier. No, to test whenever to do the flame test, we keep every sample on a blue flame, and the color of the crystal, when the crystals burn, you will observe a different color. Like with copper, due to the copper, you are getting, a blue green flame. In the same way, when if you put this any compound having a sodium ion in it, in the blue flame, you are going to get a yellow flame. Okay, so every sample has been tested using a blue flame. Okay. Plan an investigation to show which of the two different samples of baking powder has been stored for longer. So you have to understand this. And if you will understand this, you are able to attempt the question. Your plan should include the use of common laboratory apparatuses. The two samples of baking powder and water, no other chemicals could be used. Your plan should include the apparatus needed. Okay. So obviously, we are going to need a balance, right? And why we need a balance? It is because we have to keep the same mass of the two samples, right? Then we are going to heat them. And so to heat them, for example, we are going to put them in a test tube and gas syringe where the gas has been collected, and we record the volume of the carbon dioxide that has been prepared. So apparatus needed, the method to use. Now we have to explain how we do it. So record and the measurements to take. So we are going to explain that both the things. Record the mass of both samples. Then add excess water as they have shown. Water on adding water, uh, carbon dioxide is released. Measured. Yes, that's what we are doing. I have mentioned over here gas syringe, isn't it? But we need to measure the volume mass of both the samples, because we must know, we must use the equal mass of both the samples. Then we are able to identify which is going to produce a greater volume and which one is going to produce the smaller volume. The one which is producing the greater volume is the newly prepared, and the one which is producing the lesser volume is the one which produced earlier. Measure the volume of gas formed. So if you see, we are done with both the things. Now variables to control. So the variables must be one thing, that same mass of both the samples. That's how we are going to identify which one is producing the greater volume. Yes, Ahmed Mustafa, is this understandable? Same temperature must be there. Both the samples have a same temperature. Why gas syringe as well? We are using gas syringe. No, measuring the mass is very important, Zainab. It is because if you don't measure and you don't take the same mass for both the samples, then how could you compare which one is producing the greater volume? Did you understand or not? If there is any other confusion, please ask. Okay. So same mass of both the samples, same temperature, and measuring the volume of gas till no further change for both the experiments. So these are the control variables for both the experiments, for both the samples. Is this clear? So we are done with this. How to use the results to determine which sample has been stored for longer. Sample in which lesser gas is produced is the one which is stored for longer time. See? So that's how we conclude the results. I hope it's understandable to all of you. Okay. So here we have ended the paper. Now in the next class, we are going to do one more paper, but tomorrow we will not going to have any class. We are going to continue from the day after tomorrow, because the day after tomorrow we have a actually